when we have two functions which are multiplied with each other, or product of two functions, we could use some theorems in Laplace transformation. So one of which is the shifting theorem. So shifting theorem gives an easy way in getting the Laplace transform of a function. So if a function is multiplied with an exponential function. So if a function is multiplied with an exponential function, okay, so as long as we have whatever is this function, as long as it is multiplied with an exponential function, so we could use the Laplace transform. So in doing so we have to get first the Laplace transform of this function, okay, and then afterwards, so we're just going to shift. Okay, so we're going to shift the Laplace transform into an n unit. Okay, so in short, we're just going to change all s into an s minus n. Okay, so all s into an s minus n. So that is our shifting theorem. So this is simpler. While there are cases that for example this, so we have, okay, so we'll just proceed later on for the examples. So there are cases that if we have a Laplace transformation, so involving a function, multiplied it with an algebraic function, t raised to n. So in that case, so this is not e raised to nt, so this is t raised to n. So if a function is multiplied with t raised to n, so this is our formula. So negative 1 raised to n, and then the nth derivative, so with respect to x, of the Laplace transform of f of t. So our first step is we're going to find the Laplace transform of the f of t. And then depending on what is the power of t, okay, or what's the value of n, so that is how many times we're going to derive the taken Laplace transform, and then multiplied it with negative 1 raised to n. So those are the two theorems, okay, or principles that we will be using in finding the Laplace transform of product of two different functions. Let's have our example which uses the theorems that were discussed a while ago. So the first one is find the Laplace transform of f of t raised to 4 e raised to negative 3t using shifting theorem. Our f of t is equals to t raised to 4 and then e raised to negative 3t. So in finding the Laplace transform of this, so since it involves an exponential function, so f of s then would be equal to the Laplace transformation of t raised to 4. And afterwards, so we're going to shift all s into an s plus 3. So as suggested by e raised to negative 3, so that would become s plus 3. So in here, so the Laplace transform of t raised to 4, so using our table, so that would be an n factorial, that would be 4 factorial divided with s raised to n plus 1, so that is s raised to 5, and then s will be shifted to s plus 3. So our f of s then would be 4 factorial, and that would be 2 times 3 is 6 times 4 will have a 24 over, so s would be changed into s plus 3 raised to 5. So that will be our Laplace transform, so using the shifting theorem. So 24 all over s plus 3 raised to 5. Another example, by this time, so we will be using multiplication by t raised to n formula, although it is still possible to solve this one using shifting theorem, which I guess is easier. But just to use the formula, our f of t is t e raised to 2t. So our f of s then, so our formula would be negative 1 raised to n. So our n is 1. And then the first derivative, so the first derivative of the given function, so with respect to s, of the Laplace transform of e raised to 2t. So in here, so our f of s would be negative the derivative of e raised to negative 2t, so the Laplace transform is 1 over s minus 2. So f of s then, so would be equal to negative, and then the derivative of this, so we could change this into s minus 2 raised to negative 1. So f of s then, so would be negative negative 1 times s minus 2, and then raised to negative 2. Derivative of s would be 1. And thus, our f of s then, so would be positive 1 and then 1 over s minus 2 squared. So 1 over s minus 2 squared. So that is using the formula. Okay, so for the Laplace transform of the given function, so using multiplication by t raised to n. Let's have another one. Okay, so this one, so we're going to use the shifting theorem. So for our hyperbolic function, so f of t, a product of exponential e raised to 3t, then hyperbolic cosine of 3t. So using shifting theorem, so our f of s then, so would be the Laplace transform of hyperbolic cosine 3t, and then we're going to shift s to s minus 3. So our f of s then, so cosine, so would be s, and then divide it with s squared. It is hyperbolic, so that would make it negative. So 3 squared would be 9. And everything so would be shifted to s minus 3. So f of s then would be s minus 3 all over s minus 3 squared minus 9. So f of s then would be s minus 3. So we'll have s squared minus 6s plus 9 minus 9. So that gives us f of s to be equivalent to s minus 3 all over. So 9 and 9 would cancel out. However, we could factor out s, so s minus 6. So s minus 3 all over s times s minus 6. So that would be the Laplace transform of the given function. Okay, next we have find the Laplace transform of f of t, so which is t squared sine 2t. So by multiplication by t raised to n. So our f of s then, so would be negative 1 raised to 2. Then the second derivative of s of the Laplace transform of sine 2t. So f of s then, so would be the second derivative of the Laplace transform of sine 2t, so which is 2 all over s squared plus 4. So f of s would be the same as the second derivative of the function. So 2 s squared plus 4 raised to negative 1. So let's try to find the first derivative. So the first derivative then would be a negative 2, then s squared plus 4 raised to negative 2, and then we have s squared to be 2s. And thus, our f of s then would be negative 4s, s squared plus 4 raised to negative 2. And for our second derivative, f of s then would be negative 2, so we'll have 8s times s squared plus 4 raised to negative 3. However, we still have derivative of s squared, which is 2s. Then plus, it should be minus 4s, and multiplied it with or derivative of negative 4s would just be negative 4, multiplied it with s squared plus 4 raised to negative 2. Thus giving us the f of s to be equivalent to 16s squared all over s squared plus 4 raised to 3, then minus 4 all over s squared plus 4 raised to 2. So combining the two, we have s squared plus 4 raised to 3. So that is 16s squared, minus 4 times s squared plus 4. And thus giving us 16 minus 4 will have 12s squared. So minus 16 all over s squared plus 4 raised to 3. So that would be the Laplace transform. And let's have our last example. So this time it's a combination of 3. So we have the Laplace transform of t e raised to 4t, then hyperbolic sine of 2t. Although there are two ways on how to do this one. So we could either use shifting theorem first and then afterward derive, or we could use the multiplication by t raised to n, and then afterwards we're going to shift. So I think the easier one would be multiplication by t raised to n first, and then before we're going to shift. Because if we're going to shift right away, so we'll have a longer function to derive. So in this case, our f of s then would be multiplication by t raised to n, so that is a negative 1 raised to 1, then the derivative of the Laplace transform of hyperbolic sine of 2t, and afterwards we're just going to shift it to s minus 4. So our f of s then would be negative the derivative of for hyperbolic sine, so we have 2 all over s squared minus 4, and then shift it afterwards to s minus 4. So f of s then would be negative, and multiplied it with negative 2, right? And then I'll have an s squared minus 4, so negative 1, negative 2, or sorry, negative 1 minus 1 is negative 2, and then multiplied it with derivative of s squared, so which is 2s. And the answer here so would be shifted to s minus 4. So f of s then so would be positive 2. So we'll have 4. I think that would be 4s. And divide it with s squared minus 4 raised to 2. Shifted to s minus 4. So f of s then would be 4 times s minus 4. And divide it with s minus 4 squared and minus 4 squared. So lastly, our f of s then so would be 4 s minus 4 divided with s squared minus 8s. We'll have 16, positive 16 minus 4, so we'll have positive 12. And then square it. So that would be our final answer. So 4s minus 16, so s squared minus 8s plus 12 raised to 2. And that is all about Laplace transformation. Thank you.